Hi guys, I'm Josh and I work at Bedak, and I'm going to take you on our journey how we went from tickets to CRD, enabling a truly Kubernetes-native data center. But first, a few things about me and my employer. I'm Josh and I work as a tech lead for Kubernetes, for the Kubernetes platform, and I mainly focus on the platform and all the things around cloud native things. I am really passionate about cloud native, and I am in love with climbing besides Kubernetes. Bedak, especially the Bedak data center, Bedak itself is around. Bedak has around 400 employees, whereas I think around 70 to 80 of us, we work at the Bedak data center. The Bedak data center, we provide IT services for the canton of Bern, so we work in the public sector. And I'd like to show you now where we come from, our painful past, take a look at how we went about building our platform, taking a little look under the hood, and give you a few lessons learned and end up with a demo. So where we're coming from is the ticketing era. I think it's our painful past. And a ticket is basically a service request. So it's like if you need something, you need a virtual machine, you create a ticket. You no longer need this virtual machine, you create another ticket. You need a load balancer, you create a ticket. Ending up with this huge mess of many different teams providing their services. They're mostly platform as a service plus services. Because if I get a virtual machine from Bedak, it's like enabled with patching, with hardening, and so on. If I get a bucket, it's already prepared for lifecycle policies, and it's more than just a platform as a service. And each team is basically doing what they do best. So one does automating through Ansible, another uses PowerShell, yet another team uses a CLI, and a few others maybe just click it all together by their hands, ending up with 100 different solutions. So not only that, but when I start building customer value, so I'm tasked with building a web server that's enabled with maybe an S3 bucket, maybe some Kubernetes workloads, and secret management. I'm creating dozens of tickets. So I'm creating, asking for a Kubernetes tenant, I'm asking for a virtual machine, and each of these tickets, they get processed by these teams individually. Some tasks may get forgotten, some other issues show up, and maybe 10 days later, I am presented with the IP addresses I finally require to create my firewall request. Well, here I go again, waiting another 10 days until maybe this firewall request is implemented, and 20 days after I've started, I can finally start building value. And this was really hurting our time to production, because imagine you get 30 days and 20 of them are spent even getting started. And we knew something had to change, right? It couldn't go on with that. And we tried many different things. I just picked out the main solutions and anchor points. So our ticketing era, the portal era, was maybe mid-2010s or somewhere around 2016. And Terraform was all the hype around 2018. And we took a look at Terraform. We kind of were a little bit, it wasn't there yet, like conditionals weren't there where they are right now. And a few things were missing. And just let's be honest, we kind of weren't even ready yet. So it's not like Terraform itself was the issue, it's also us. A few years down the drain, we thought to ourselves, well, let's just try again because it worked so great last time. And well, we didn't have a Terraform ecosystem. If you don't have a Terraform ecosystem, you first need to have and build an ecosystem. And Bedak, being around for around 30 years, you can only imagine how much legacy infrastructure we've collected over these years. There's like no providers for most of these technologies. So what do? Well, you have to write these providers. And if you write providers, you have to write SDKs because, well, they don't exist as well. If you're at that point, you kind of take the low-hanging fruit of, well, let's just get started with a CLI first. So we can get our hands dirty and add some quick automation. But the CLI is an admin-only tool because there's no RBAC, there's no quota. Well, there is, but it's just not solved, right? So what do you do to solve caching for RBAC and so on? Well, if you're on this custom train, you just go ahead and reinvent the wheel, writing a custom API server all for yourself. It's right about that time where we were redesigning our Kubernetes platform and also thought to ourselves, well, Kubernetes has this already solved. And why build next to Kubernetes, reinventing the wheel, if we can build on top of Kubernetes? So it already matched our ecosystem. Like we have experience for many years with Kubernetes, and it has all of these RBAC and quota and whatnot baked in and solved already. And I think I took a look at it before I finished the slide. We started Kubernetes with the version 1.5, and we've been running it productive around 8 years. So we have the maturity to really get started with Kubernetes. And I'd like to focus on this time window now, where we kind of realized we wanted to build on top of Kubernetes besides, instead of building next to it. And we took heavy inspiration from many different platform talks, whereas any resource can be a custom resource. So most of you are familiar that Kubernetes by now is much more than just a container orchestration engine. So you can build on top of this Kubernetes resource model and just have anything as a custom resource. So we're using known patterns for our platform, and we decided let's just have anything as a CRD. So I have full flexibility and everything is declarative by design. So where possible, we're using existing operators. Where required, we create our own kube builder operator, and if possible, we bridge the gaps using crossplane, which really allowed for anything as a service. But there are still a few issues with just that, because Bedak has a little bit more than one Kubernetes cluster. Maybe have 50 Kubernetes clusters, whereas 20 of them are shared for our users. So this doesn't really scale with just one cluster. You're just missing this central developer interface, and it's a really painful experience for a multi-cluster setup. And there's really no integration into our existing ecosystem, because yet again, Bedak has been around for 30 years. There are external databases, there are existing processes. We need to integrate them into Kubernetes for this to really make it work. Yeah, because we need all of this company metadata. So there we need a central control plane. Well, what do? You look around the Kubernetes ecosystem, you kind of realize, well, why not create it ourselves? Just fully matching for, our organizational needs. So we built this custom control plane around our very own internal developer platform, allowing for a centralized view, which allows for a unified developer experience and allows us to join our existing Kubernetes fleet. So it allows for a much cleaner multi-cluster experience. But yet again, with just that, there are still a few issues. Like all the data in Kubernetes is still in etcd, missing yet again the billing. So what do you do about the billing? Also, Kubernetes has this solved. Well, there are many different tools that solve this. And for example, the metrics server is a well-established tool with an aggregated API. So what do? You create your own aggregated API server for you to integrate your existing billing metadata into your Kubernetes, so you get access to an external database, allowing you for a unified consistency. So each Kubernetes cluster allows creation of data center services through custom resources. They are linked together with a central control plane, and the billing and other company metadata is being provided through a custom API service. So it's really then where all started to click, and we knew that's something where we wanted to go. We only needed to build it, right? Easier said than done, obviously. And we started to split our central control plane into basically 3 parts. It's the clusters. It's what you saw before, our whole Kubernetes fleet, where our users are actually consuming their services. And we need some layer, an organization, just like in Azure, you have your canons. We have our organizations. These organizations are the anchor point of our Bedak cloud, of our control plane. And they get enabled with services. So it looks something like that. You have your organization in the control plane that gets enabled with a subset of the available cluster, because not every customer needs all of our 50 clusters. and the required services. So an organization is a platform as a service customer. Usually it's like a DevOps team, more likely an ops team than a dev team that consumes data center services. So these are teams that create virtual machines, they create load balancers, they provide the actual value for the users. These organizations are also, just like within Azure, they create subscriptions. A subscription is where they configure their need. So in each subscription, they consume the available services. So a service is, well, it's basically a service as a service. It's the cloud service. It's an interface that where I, as a platform owner, so me as the Kubernetes platform guy, we provide our service through a cloud service. So we create this service instance and giving it to our customers. These services, they are in a whole catalog. So any of our data center services, like the virtual machines, the Kubernetes, the load balancers, and so on, are made available through a standardized catalog. These services from the get-go were designed for scalability. So what we wanted was that each of these platform teams, they can bring their own service. So it's a bring your own service kind of way. Each of these services, if you have a little bit knowledge about object-oriented programming, it's basically just an interface. So me as a platform team, I can develop my very own cloud service as I want it, as my service looks like. So for example, as the GitOps service owner, I'm creating a service for my users so they can access Argo CD. Or as a consumer, I use many of these different services through a standardized interface. This allows for both a unified experience for our customers. So for a customer, each service looks the same, but the same goes for our platform teams. For each of our platform teams, they just have to implement a standardized interface. And I'd now like to show you what it means creating these services, because having a standardized interface is not really all there is, because as Bedrock, we have yet again a few legacy services, and I'd like to show you with a model what this can look like. We already know the Kubernetes resource model. It's just a controller reconciling a custom resource. So building on top of that, we have our cloud service, the service abstraction, and maybe optionally custom governance or custom automation. So what this looks like is me as a service provider. I need to provide a controller that makes my service available. I then wrap this controller into my standardized interface so our users can consume it through a standardized way. And if need be, I add some governance to be compliant with security. And we just took a look around the Kubernetes, the CNCF ecosystem, and just reuse anything that's available. So for base Kubernetes, it's really easy because I tried to visualize it a bit through a gray tone that the base Kubernetes controllers allowing for pods, services, and so on, they already exist. So I can just reuse them and add a tiny wee layer for the cloud service abstraction. For example, to set a few guardrails, set limits, or create role-based access. And obviously for Kubernetes, for our workloads, we want to enable some PSS, some pod security standards. So we add a layer of governance on top. With Cert Manager, it's the same. It's really just the same. You need a controller. We have the Cert Manager already existing, already used it. You need a little bit more effort to get it into your ecosystem, because you might need some cluster issuers. Not everyone should get access to all of these cluster issuers. So the effort to integrate it into your cloud is a little bit bigger. And you yet again add some governance or automation on top of it. For example, restricting the DNS names that can be accessed. And the more complex an operator is, the more effort obviously goes into that. Like for Argo, you want to have least privilege. You want to have the users locked into their service accounts, so they can't impact each other's, which yet again just takes more time for you to integrate it. It really gets interesting when you start stuff like Vault or Grafana or GitLab, where your service fully matches what a cross-plane provider can do. So for Vault, for example, we wanted to create a Vault engine as a service construct where each user can create and consume their own Vault engines. The cross-plane provider matches perfectly for that. So we just reuse the existing thing from the cloud-native ecosystem, create their composition, and voila, we have a Vault engine as a service. It's a little bit more complex for more refined services like the virtual machine. Like, for example, you need to have patching, you need to integrate it into your hardening, you might want to add automated integration into backup, and so on and so on. And for all of these solutions, there was just not this one-size-fits-all operator that does it all. So we fell back on the Kubernetes Kube Builder framework and created our own operators. In some cases, we had to write our SDKs, create this operator, wrap it into the cloud service interface, and yet again, we have a VM as a service made available. And this just goes on and on and on. So for other things, like for S3, mind you, it's NetApp Storage Grid S3, not AWS. Would have been much easier if it would have been just AWS. There exists basically nothing, so you have to write your own SDK, create the operator, add cloud service definition, maybe even add governance on top of it to enable or enforce certain security guardrails. And you now might ask yourself, well, why are you using Crossplane and Kube Builder? It just boils down to we want to use the best tool for the job. So we reach for Crossplane wherever there is a Crossplane provider already bringing everything we need, meaning already bringing the engines, already bringing the data sources for Grafana, already having GitLab groups enabled, and we just need to stitch this together through a composition. In cases where it gets more complex, where we need more flexibility, we just fall back to Kube Builder. And Kube Builder, it comes with more complexity. But with the complexity, there's also more freedom. Since we're already building our control plane based on Kube Builder, we have the required know-how using Kube Builder. So it's just a trade-off of reusing existing tools compared to writing it ourselves. And finally, there are still cases you might want to combine these tools together. So if you have really, really complex controllers, instead of going ahead and just writing another controller, you can make yourself the life a bit easier by just creating an easy and simple crossplane composition. And I'd now like to show you what this can look like. So let's go back to our initial use case of a user, of a customer requiring a web server with a virtual machine and with pods that have a load balancer in front of them, and these pods and virtual machines return, whoops, they are switched, these logos, return objects from the S3 bucket or data from secrets from Vault. And I've prepared a quick demonstration. Let's just pray everything works as it should. And this is RunMe. It's like Jupyter Notebook for VS Code. It's just what allows me to have this, to streamline this whole process a little bit more, for me to just be able to click through everything, to not mess up things or forget what I actually wanted to show you. And we have our own control plane. The control plane is built on Kubernetes. So everything you see now is just a Kubernetes resource that's being visualized through a UI. I just hope it's performant enough because I'm running through a hotspot, and I prepared this organization, the Cloud Native Zurich organization, and me as a service owner, as one that is tasked by to create the customer need, I just go ahead and I create a subscription. And I've already prepared a subscription because it's going to take a while to create the virtual machines and so on. But I'd like to show you what it looks like. So our customers, they just go ahead and create this subscription for their customers. They go ahead to the service tab and just enable anything they need. So for example, I know I need virtual machines, so I just enable them. These services, these standardized interfaces, they have requirements. So for example, each virtual machine requires a tenant. The tenant yet again has another requirement. So I just go through this, this wizard, enabling all of the services I require. For example, I want Argo CD, I want container workloads, I require secret management, I need S3 buckets, I want the load balancer, and the load balancer yet again comes with a few additional requirements. These services might contain a few parameters, and I'm going to finish through this whole experience and jumping to the end of it. You will see there's like, it's telling me already I'm too lazy and I should fill in all of the fields. And even this, it's a Kubernetes resource. So what you just saw me go through, clicking it, enabling it, can be GitOps and created through automatically. And let's go back to my IDE. And we can see that, for example, I have this subscription enabled. And we get returned with our subscription, our Kubernetes resource, the subscription itself. And we can just go through. I've prepared the commands with YQ filters. And for example, we see the services that have been enabled in this subscription. And now let's go with our web server example. I created a config map having the web server configuration. Only relevant thing is like it's running on 8080. And I went ahead and created a Vault engine. And this Vault engine, yet again, it's a Kubernetes resource. So I see it's the engine with the mount point, cloud-native Zurich demo, and it's a KVV2 engine. And now I can list my secrets using the Vault CLI. So it just redirects me to the OIDC login. Let's go back to the editor, and we see there's the key test. And I can now combine this together with a Vault static secret that references the cloud-native Zurich demo, and yet then creates this my app secret. So we can see the keys in this engine, and we see that it's owned by the Vault static secret you saw before. The same goes for the S3 bucket. So I just go ahead, that's now our own custom S3 bucket, get the S3 buckets, I check out the connection data, it's just a secret. It's just a secret showing the So I maybe must have messed up something with the configuration, but it's like a secret that returns that has the connection data for the S3 buckets. I create a virtual machine, but now it's where the things really start to click. So for the virtual machine, I can create mount points. So I mount these connection data, I mount the secret, I mount the config for the web server. I do the same for the deployment. So I just mount the secret again. And now I can start testing it. So I can send a curl to the web server of the VM. Let's just skip a little bit over. I can do the same with a web server, load balancer. So I just use Gateway API, configure an HTTP route, and have a backend and the web server service. And I can start sending curls to that. So it's just 5 curls after each other, where you can see it's like the here we see the web server, that's the container, the pod. In this case, it's the container on the virtual machine. And we see that the curl is being load balanced on both endpoints. And then I go through, I mutate some resources with the AWS CLI. So I'm just running a kubectl exec. And you see that I'm listing the demo file. And now I get the demo file. So it's like S3 demo, and if I get this file now, I see hello cloud native Zurich on Thursday, just right now. And all of these resources that you just saw, it's just a Kubernetes resource. So it can be automated altogether. And this really allows for a streamlined experience. Or users, they can just, instead of creating tickets, they just go ahead and create Kubernetes resources. And this, and this is what really saves us time in the long run. So we went from tickets to CRDs in a really, really cloud-native fashion. And finally, this data is then collected in the dashboard of the subscription. And if we take a look at this, we can see that the user, what the user is actually consuming, allowing for a unified billing experience. And this is what's really starting to allow us getting to production much faster. And I just was able to specify what I need in my subscription. So the subscription is like the container for the users, where they tell what they require. And me, as a developer, I just create a few custom resources through self-service. I don't have to wait. I just say what I want, how I want it, and I automate it all through code. So it's no longer this ticket mess. But this comes with a lot of challenges. And I'd like to show you some of these lessons learned and the challenges we're facing. And engineering is the easy part, right? Because writing a controller, it's just logic. It's easy and straightforward. What's not easy is onboarding your users and having understandable and easy to expect patterns. And since you have your own business, you have your own processes, and there is no tool that fits all of your needs. So you must build the glue yourself. We kind of realize there is no one size fits all tool. And us having a lot of legacy, we had to realize, well, you kind of need to make it fit. So some of your platforms, like old platforms with DNS, you need to rethink these designs for them to make it work in a cloud-native fashion. Not only that, but shifting to a Kubernetes-native experience leads to a huge culture shift. People need to start fixing it themselves, start to create it themselves. They cannot only create a ticket and throw it to me and I'll have to figure it out. So you have to provide standardized guides and really be prepared to deal and help your frustrated users. Because Kubernetes really is complex, and adding internal abstractions will not make it easier. So you really need to slow down your pace and adopt new technology sparingly and standardize your tool stack so it's just one unified experience. And finally, maintaining CRDs is really hard work, because if you don't invest your time beforehand, you will have to invest double the time later down your journey. And we are still very far from done. While we do have a few services already, we need to invest much more time into GA. We want to add things like assistance, create better end user experience. But all in all, we are really just adding everything to the same control plane now. We have this one unified experience. We're just building on top of the Kubernetes ecosystem and can both provide a unified experience for our users as well as for our service owners. And with that, I'd like to thank you for your attention, and I'm ready for any questions.